So welcome again, everyone. Today we'll go through part 2 of the system design basics session. Last time we couldn't cover so many things. So let's see what we can cover this time. Just to tell you what we will not cover for sure, I think, unless we have time in the end, we'll not cover authentication, authorization, will not cover security, batch processing, how to orchestrate the batch jobs, because when you run the batch jobs you need to orchestrate to get the overall output. You may also run some machine learning algorithm on that. Will not cover that. Will not cover analytics, will not cover streaming, will not cover logging, metrics, deployment strategies. Then what we will do? So that's why, there are so many things that we cannot cover, which makes this thing pretty, it's very vast. So before that, actually, just to make sure that everybody starts to chime in, I will ask a question. And also this session is not well planned. So it could be it may take me some time to think about scenarios, and then I may ask you question, because when you will try to answer the question, you will remember for a long time, and others will also remember for a longer time. So we'll go in that way, hopefully. So my first question is actually asked by someone on the thread, and I will take a, first I will like you guys, one of you to answer that is, can we get better at system design by reading blogs of technical companies? Anybody wants to answer that?
My personal opinion is that if somebody actually has some experience, then that person may get some benefit if they have basic building blocks and have some exposure to the system design.
Mm-hmm.
So they may get some benefit. Definitely, they will get some benefit to going through those blogs.
Right. So you're saying, yeah, if you know a little bit, then you will make sense out of whatever you read, at least some percentage of it, right?
Yeah.
Yeah, I do agree. Anyone else wants to say anything about it?
Yes, from my experience, most of the time, reading blogs misguides you. So, in my own experience, I have seen many systems failing, but they will say otherwise in the blogs. For example, let's speak of non-blocking asynchronous web servers. They usually don't work. But in the blogs, you will find like someone will do a simple call that doesn't even end up in database, that just does a simple hello world or simple function run. And it does it more than a simple synchronous servlet. And people will start claiming like, if you design it this way, you'll have a high throughput, low latency server. But in experience, it doesn't work. So I would say hands-on experience with some good amount of stress testing. You should have the right tools as well. They are necessary whenever you speak of system design.
Right. That's a good point. On that, I would say so two things. One is, here also depends, like if you are reading a blog, which somebody who is working in a college, has no experience or hasn't built any big system, anybody can blog, right? They can blog a lot of theoretical things. It looks good, but eventually it may not work. But what, the question was well proven systems, they will also, they should talk about when should you use it. There will be advantage, disadvantage, and no system is perfect, right? You can't build a perfect system, it is impossible. So with that, yes, you will get some ideas. Maybe you will not actually solve the problem in hand, but maybe you will come across some use case where you can use it and it will buy you more time. And actually you can even as a cloud provider, the theory you will read in these blogs, they may be talking about hey, you cannot you have to think about your, for example, partitioning scheme, for example. But now suppose like somebody who has no idea about partitioning scheme, he said, okay, whatever is the default, let me do that. It will start working for sure for some time. As like, the traffic grows, there will come a point of time when, like, you have to repartition or you have to figure out things, and that will involve like a lot of pain, cost, other things. But yeah, so both ways, it works both ways. It may help you. At least for me, I will say there are two things. Some of the things I know, but there are a lot of things I don't know. So the areas which I don't know, at least by going through this blog, it makes me curious to check that out. So I would highly recommend go through some good tech blogs like Netflix blog, and like there is highscalability.com. There they, like, a lot of companies put their, like, architecture and the other stuffs. Yeah.
Uber lifts are also good actually.
Yeah, go ahead.
No, no, no. And the tech blogs of Uber and Lyft are also good actually.
Yes. So I do agree. So go take a look. You will learn a lot. At least you will learn more than what we are going to learn today for sure. With that, let's start today's session. If nobody has anything to say on that. So I will think about a scenario and you guys will help me to solve that problem, for example. So suppose, can I draw here? Yeah, I can draw here. Suppose there is a client makes a request to one of my service, and suppose I interact with 3 of my other services. Maybe the client is like, sending an order or something. I may be looking at my inventory system. I may be looking at, okay, payment processing system, and I may be looking at, finally, if this works, then maybe like email server, which will confirm the client that, hey, yes, your request went through and this was your order, we charge this much. So let's call it email server. This was payment processing, or maybe wrapper around payment processing, because you may use some other service. And this was like, say, inventory system, for example. Now, the problem now I have with my service is that there are a lot of problems, but just like, what I want to come up with, that this client, it doesn't care if I, like, send the email right away, for example. And like, inventory system, like, it is okay, for example, for my customer experience, that I can tell the customer, hey, sorry, we didn't have enough things in our stock, we'll inform you later. So client is okay with that, or at least we have decided that this customer experience is good for our system, for example. Now my problem is, this client calls us and I make a call, first call here, second call here, third call here, and my system is not able to take other calls, or maybe like there are only a couple of clients which can make a call to my system. So what should I do? Anybody?
That's
Sort
where
of,
we
could you
need to
repeat
decide.
could you repeat what the problem here is? What you are trying to solve here?
Yes, sure. So here is the client, here is my service. My service is S. It depends on 3 other services. Let's call it S. This was S0, S1, S2, S3. So client makes a request. Now S0 talks to inventory system whether there is enough stock or not, and then it calls a payment service to charge the like customer, and then S3 sends the email to the customer for confirmation. Now the problem I am in that it takes long time, and I have already thinking that client doesn't care whether I send the email right away, uh, and if it's okay if I can tell the client, hey, there was not enough inventory for some weird use cases. If inventory was out of stock, it's fine. So what should I do?
So the email can be sent asynchronously on the completion of your second thing, which is payment processing, because payment processing depends on inventory. So you'll have to lock on inventory, you complete the payment processing, and when it's done, only then you send an email. So a future or a completable future can take care of that because you don't need it in real time. On the other
Okay.
hand, to take care of the entire system, you will have to think that, do you need non-blocking threads? Because if a thread is blocked on when you send out a call to S1 inventory system, let's say it's a database call, which has a huge database in a relational database, it might return you result in 1.2 or something seconds, right? More than 1 second, let's say.
Mm-hmm.
You don't want to block your thread waiting for the result.
Okay.
That's where the non-blocking paradigm comes in, based on the future or completable future.
Okay. So asynchronously, like everybody agrees to that idea, or has some other things to talk about?
Can I add one thing? So I was thinking that depending on the traffic on each of them, right, inventory or payment processing,
Mm-hmm.
that possible we can consider scaling them separately, because I mean doing something around scaling independently, since these are independent services.
Right. So
Like
you have
figure out what's the bottleneck. Is there one service over the other that's kind of blocking? If
Mhm.
then we can consider scaling them separately.
Right. That's a good thought. But think about like when I will send the email at least to the customer, it's better to not send him multiple emails like, hey, we
Yeah.
like, right. So I just want to send a final email.
Mm-hmm.
Doesn't matter how long it takes, at least for in couple of minutes, I can send it, not instantaneously. Right.
Right.
So,
Another solution could be on the completion of your last step, payment processing, you send it off to a queue, which actually is received by another server, which is actually listening to the other end of the queue, and then it sends the email.
okay.
This is also how you can break it. So the increasing load on the server will just delay sending the email. You wouldn't have to increase more server capacity. These are different parameters in which you control the cost of the server as well, because yes, you can add more servers and it will take more load, but then you have to figure out how many number of requests can be processed by a single node, because that's where the money goes.
Right. Yeah. Makes sense.
So are we, at least don't go too much in implementation. That's not the idea of this course, but are we agreeing that, hey, like if the request comes, put something here and return the response to the client right away? Is that what we are talking about?
That's not what I exactly said, because this will bring up new questions. So in this situation, the client once receives the response, you will also have to provide him a transaction ID, and the client will have to keep polling that did my transaction complete. Or the other way, you say the client to the client that fine, wait for the result or wait for the email to arrive. Once you receive the email, you will see what happened. But then we are ignoring other aspects, that how the payment processing will work. Because for the payment processing, we are assuming that client will be asked to provide the payment method, like credit card or something, which is an interactive step.
Okay.
So for this step, you cannot just receive the request and respond with the transaction ID, and then the client will receive an email. No.
Okay. So just to make sure that idea for this example is not to build this system. Is that clear? Like idea is that if somebody who has gone through the previous session, like we didn't talk about this particular asynchronous component at all, if you remember. I want to bring that to attention that it's possible that some of the times you have to like you should actually think about it, that maybe client doesn't care the answer right away. Like you are going for like, going to Starbucks, you ordered your coffee and you are like just standing in the line. Wouldn't it be better you go to your seat and like, keep an eye on when your order is received, well, actually is completed, you go there and just go ahead with your business so other customers can actually continue, right? So I do agree. If you have to actually build all these three things, there will be a lot of complexities. But the idea was this thing, this new component, we can just, leverage this thing.
Here, Roger.
Just one. Sorry, go ahead.
Okay, so I will say think in that way because I have seen similar problem before also. So think in that way. You have put everything in your cart. You put a pay. You also put everything, Visa card, everything, and you press that uh, checkout thing. Like you're already in that mode. Now, generally, like Roger mentioned, it has to go through everything. A final check of inventory, payment, and then email. So that could take long time based on different latency of different components. But what if I do, I just put them in a queue, like Roger mentioned, and just returned a response back accepted that we accepted your thing, but we'll notify you later based on inventory, payment, and other things. So now I can process them asynchronously on the speed which I can process. And this could be a perfect example of something like a Prime Day, when your load could be suddenly could become in millions. So you can't immediately scale your all components S1, S2, S3. And might be S1 component is in your control because inventory service could be yours, email could be yours. What about payment? You're trying to call some other vendor like Visa, MasterCard. That could also go down. I can scale some component, but I could not scale all the components. Now I try to bring something asynchronous processing, at which rate I can process things rather than the incoming load.
Yeah, makes sense. Thank you.
I was also coming to a same point. I mean, if many of you guys have faced this thing when you make a payment on Amazon.com, it completes there and says your payment is still in processing. And
Right.
you can check back in 15 minutes or something like that.
Right. So thanks for coming, guys, like, coming forward. So definitely, like, every input was useful. And I totally agree that we are not building this system because there will be a lot of complexity. But the idea is like, which everybody agreed, that we should have something asynchronous so that client just returns with a response, hey, my request has been taken and I will be notified when things are ready, right? So there we just introduce this message queue thing. And again, uh, can someone tell me like which kind of message queue in industry you have used or you think you will use, just so that others know a little bit?
So we can use two types of queue, like FIFO or a standard, like generally where the delivery order of delivery doesn't matter. Generally, I think FIFO queues are little costly because it maintains order in which message came. But if you don't care about order, you can even do something like standard where the
So
sequence doesn't matter.
yeah, I my question was like more towards like technology specific, like,
Oh,
yeah.
yeah. So there are different things. In Amazon, it's a simple queue service. There are from TIBCO, there is a EMS, enterprise messaging service. These two ones I know.
Okay.
I've used Azure Service Bus, storage service queues, and RabbitMQ.
Service bus, RabbitMQ. Okay.
Kafka.
RabbitMQ. Somebody said
Kafka.
Kafka.
I won't consider Kafka as a queue. I will consider more as streaming. It's as good as queue, but it's
It's actually a message broker which can be used for the streaming. So essentially, it can be used as a service, queue also, but not with that stringent rules of having a first in first out with priority.
Redis has a queue as well. We use
So yeah, one idea in Kafka, it could be like if you put that information, there could be multiple consumer for that, right? So
Fucks up kind of architecture.
yeah, yeah, sure. So again, if you have to just build this, like we can call this distributed message queue, that would be a question and design in itself, right? Like again, you have to think how would you build this distributed message queue? So that is not currently like the scope. So we'll just stop there. Anything else we want to add before we move ahead?
One
So
more way to add use Redis as a queue as well.
Redis
Uh,
queue.
Cache as a queue actually with that.
We do have Solace also.
Poly,
Solace,
can you spell?
Solace, Solace.
Oh, I haven't heard about it. And I can't write it for some reason. Okay. So
Solace.
CE.
Yeah.
Okay, so less. Great. So that's it. Okay, one more question. Like in this particular case, the customer was a person. Suppose we have different microservices, or maybe there's another service which was actually calling this guy. So now how it will get notified, because email doesn't make sense to him, to this client.
I have a question. What if the queue grow too fast, or the queue grow exceed the limit size?
So what will you do? Like if queue is growing, that means the consumers are not trying to catch up, right? They are not catching up, or maybe your queue is poisoned, right? You have a thing which you are again putting back, right? So if your clients are like, there is too much message and you are not able to consume it, then you will have to scale the processors, right? Queue processors. You will have to put more instances for processors. Other reason could be that your processors are working, but what is happening that some of the messages are not good. So what you are doing, you are putting back in the queue because it didn't succeed, and you don't have the strategy that, hey, after maybe 3 times, just drop it, or maybe send it to another queue, which you can call, in the industry, they call it dead letter queue, right?
So I think it's subject to the design and as part of every design we do system estimations. So I would say that could be a corner case as long as we can justify it. Like if I'm using something cloud technology like SQS, I can say it is elastic. I can go really high on numbers, but yes, but on top of it, then other things, other industry practices comes into picture that like on call. So definitely there would be on call alerts. As soon as it will go really high, it will trigger. People have to come in and do something, what is going wrong.
Yeah, but also the thing is, suppose if you have your ever growing queue, you will be also affecting a lot of good clients, right? I mean, at least you will process their message eventually, very late maybe,
Yes.
right? So queue will grow, you will have a like alert set on that, your on-call pager goes off, you go there, you start looking into one of the messages, maybe trying make sense out of it. But the thing is, somebody also asked, what is this dead letter queue? The thing is, like, what we are going to do it, we will get those messages which are like, failing. We'll just dequeue from there and put into a special queue, which we are calling, we can call it poison queue, dead letter queue, and we'll have different processors, which may have the same logic. So all the good people, like the good clients, or at least the other positive use cases, those guys are not affected. Only people who have their message here, they are affected. So this is a very well-known design pattern. You can look into it for details.
So the queue can grow, up to certain point, right? And then, let's say, we have a threshold, and let's say we can also scale the queue horizontally, but up to some point we have to deny, the incoming request. Is that right? Like, for example, on Black Friday, a lot of people going in and the system not really be able to handle that. What would be a proper design in this case?
So you are saying
So,
there are, go ahead.
yeah, I was just saying there are two cases in that what you're saying, like if the queue goes very large and your consumers are not able to process them. Uh, Suppose the consumers are not in your control, it's some external system that you're using. So you can, on the client side, if you're saying, or the server, you can implement kind of a circuit breaker which can stop pushing new messages into the queue if it knows that the certain threshold has reached, which would not be an ideal case for the consumers, but it can gracefully stop the processing instead of just filling on back to some errors. So there are two possibilities. One is if you are able to scale up the consumers as fast as you can, that's well and good. Everything is handled. If not, you can implement kind of a circuit breaker at your service, which will not enqueue any new messages to the queue, so it does not go out of proportion and you have some clients getting errors.
Yep. Sounds good to me. Anybody has any question? I can't follow the chat, so if there is some pressing questions related to that, please talk.
So I think there are questions around debt letter. So I will say that is just a concept, debt letter. It could be a queue, it could be a storage, it could be database, in whatever way you want to design as part of your system. It not has to specifically be a queue. If it is a queue, that is good. But if you think that can again have its threshold, you can put in like a S3, or you can put it even in like database, whichever way you want. And then you can have other processor who keep on polling dead letter and try to reprocess. Or it could be something like you don't want to process your dead letters right away. For example, there is some bug in S2 in the payment service. First, it's as good as first fix that bug and then only reprocess your dead letters, because if you reprocess them again, it will again end up in the dead letter only.
Yeah. You can have a higher let's call it back off, basically. Even before you retry, don't try that frequently. Try later. Maybe their system was down, maybe something like that can happen. So eventually it may get resolved, or in worst case, an engineer can look into it. Okay, what was going on? And then you may have to work with the service, which tells hey, there was some error. But yeah, let's not get into that too much. It's very practical. Actually, whenever you build real system, when you have a queue, you may have to think about all this, like dead letter queue. It's a very useful thing, by the way.
So Roger, I want to quickly mention 2 or 3 properties of a queue.
Yeah.
One is visibility timeout.
Yep.
So when I say visibility timeout, what it means is, if I put a message in a queue, there could be 5 or 10 processors which are listening to that queue. Think in that way, of the same service. So I don't want the same message to be picked up by all the processors. So what I'll say when I put in the queue, if it is picked by some processor, I'll say it will be invisible for other processor for like 30 seconds. So the same message should not be processed by different things. The other one is the retry. How many times a message should be retried, and then it should be gone out of the queue. So for example, if one processor reads a message and it couldn't process, it will be invisible for 30 seconds. Again, it will be visible. Again, got retried, and 3 times when it got retried, we will have a eviction policy to put it into somewhere else. It could be dead letter.
Right.
So Yes.
Good point.
And the retention period. So I know in SQS the by default retention period is 3 days, and maximum it can go to 14 days. So if you think your dead letter queue is a SQS, and then max is it will hold for 14 days, then you have to think in a way, if you are not clearing that dead letter queue for 14 days, it will go away. It will get deleted automatically.
Just one more property I would like to add. I don't know if it's a property or an attribute system, but max one-time delivery and the minimum one-time delivery thing for the queues. So I think Roger, I'm sure you will cover it, but I just wanted to cover, bring it up.
Yeah, delivery. Can you do just once delivery or max one delivery, max one time delivery, right? At most once, right?
Yeah, at most once and at least once delivery.
There is also exactly once delivery. Some queues start providing that as well, although it's difficult. So in Kafka, so based on the CAP theorem, you tune up these arguments. But I think it will be too much out of a scope for this conversation.
Yeah, I do agree.
Yeah.
Take a look. Exactly once. Yeah, these are the delivery model, but it's good. Yeah, these three things are very useful. So when we will, suppose if we do some course, sorry, not session, on building a distributed queue, then we will actually take these things as our requirements and we will deliver our system. So it's a very good input. Thanks for that. All right. So, okay, now I will change the scenario a little bit. I think now we know why we use queue, at least the basic. A lot of people who have never used, they will definitely know like when to use it. But now the problem is, so we are making call to different systems here. Okay. Actually, I had brought a question which nobody has answered yet. Let's finish that too. So I brought a client here. It's not a person. Now this client needs to get notified that, okay, whatever it tried to do has been done. How will this client, which is a service actually, will get notified?
So either it gives a reception endpoint or either it keeps polling. There are two methods.
Okay.
Third one is server-side push, which nobody uses because it's very expensive.
Could it be a callback?
Yeah, I mean, a callback is actually the one in which you, so the client will provide a delivery delivery endpoint to the server, so that when your job is complete, give me a callback at this endpoint. This is what I said is option number one. Option number two is the client keeps polling after a certain duration.
There are multiple names for the receiving endpoint, callback, or webhook.
Yeah, exactly. But the concept is same. Third one, which nobody would want to use, is the server-side push because of it's expensive, hard to scale, etc., etc.
Yeah, I wanted to bring this, which Puneet already said. This is another thing. In this, client provides a HTTP endpoint, and this server, so without going through the queue also, it can directly call this guy that, hey, I just confirmed that this was done. Other way could be like, okay, this processor put in a queue where this client can read from. So he knows that, okay, asynchronously, like, okay, this was taken care of. We can design that. But yes, I think everybody knows like how to build this kind of things in an asynchronous way.
If the processor call or notify the client directly, it's done. So is that the client still need to go to the processor to get the response, or the processor deliver the response to the client directly?
So whether processor can call it or it will delegate someone to do it, that's a design choice. But our system, some small subsystem in our system can directly call a client if client has suppose registered with a webhook URL, right? Where you can post that, hey, this was done with some maybe some ID or something. with which client can relate. Okay, what was done? I have no idea what was done. So you will put that information there. Make sense?
Yeah.
Okay, so we'll go to the next question, which let's see. Okay, now my system has been calling a lot of services. It could be my own services, or it could be like some of my partner services. Okay, so here is one service, here is one service, here is one service. So, okay. So suppose the request comes from client, it goes to this service S1, this goes to another service like SX, let's call it. Now, what we are seeing that this call is failing, like, this call has been failing. And so maybe there could be a network issue or something. But what is happening, like this guy tries, like retries, like couple of times, maybe 3 times. There are different, okay, so I will not talk about it. You guys will suggest me. What could go wrong? What can you think about it? Like, this call is failing. Maybe this server is overloaded, but maybe this server might have died also. Maybe it is not up. It is trying to recover. So what should you do? What can you do here as S1? Like suppose you are building S1.
So they have something called a circuit breaker. So if we retry so multiple times and it still fail, and so we open the circuit breaker and we run another thread to the monitor their service. So if their service up again, we will send the request to them.
Okay, that was a good idea. I think Puneet also brought this in previous discussion. So I'm really happy you guys are aware of it. So the problem is, if like, S1 keeps calling it, and now this guy actually SX is trying to recover, but what we are doing, we are not letting it recover. We are making so many requests. We are basically bombarding this service. And now this thread is also blocked. So a lot of threads are blocked here because they are still waiting for the response to get like, from here. So maybe there is a lot of gateway timeout, things are going like that. So eventually this service may also fail. Do you guys agree? It's totally unresponsive. So just because this guy was not good in a good condition, now we have also messed this service, which may mess up this service. So it will be a cascading failure, right? So for that, the person, I don't know his name, Puneet brought it up, and then there was Nugent or someone who brought up. So what you can do, you can use circuit breaker. What it does that, hey, you send a request, and if you are getting like, some like 15 errors you got in last like 1 minute or something. So you are making an assumption, maybe there is some problem with that service. So let's not call this service, right? So basically, if you think it like electric service, and this was the connection between these two services, what we are saying, okay, don't make call. That means you are changing this to this state, that this switch is like, not connected. So you can say it's open. So, okay, after maybe 5 minutes, you are thinking maybe this service is now up. So let me try once. So you will allow just just one call to check the status of the response. If the response was successful, then okay, the service has recovered. But if not, then you will continue to keep this state open.
So it benefits if there's some service, they have some healthy URL. So that means that is the GET request. So for example, they have like a healthy endpoint, and we keep monitor that one. And then when we send a GET request to their healthy endpoint, if they return up, so we know their service recover.
Yeah. And you can also provide whether a service is healthy or not, like, status using this also, right? Just make some calls regularly. But there could be also an issue with maybe network. The service was not down. Ideally, you will get a different maybe response, but you can get gateway timeout anyway. If the request received there and you didn't get a response, it will be a 504. So yeah, anybody knows any library for that, or you can build your own? Have used it?
I think in a Spring ecosystem, there is a lot of libraries. One of them is Eureka, I guess, very famous, which is by Netflix, if I'm not wrong.
Yeah,
There are many options available out there.
okay. Yeah, for C Sharp, I think it's Poly or something. It has it. Netflix has its own. And this came like, really long time back. There was a book which made it very famous, that was Release It or something. So they brought it there, and then a lot of open source projects started to implement it and provide the libraries. But yeah, do take a look. Since Puneet had brought it, so I thought, okay, I will just talk briefly about it. It's a very good pattern. Okay, with this, I think, what should we move to? Maybe one very important thing is capacity estimation. Right? In most of the design, you will deal with it. So what do we estimate in capacity estimation? Okay. In most of the design, like, you will estimate a couple of things. So what do you do? Like, maybe a very common thing to look at is like your server, how much read is there. So one good thing to look at, I don't know why I can't write it. Read write ratio, because as we talked in previous session, it may also suggest you which kind of database you want. But yeah, read write ratio, and then your request is coming to your, like, servers. So how many requests per second you can handle, right? So request per second, how would you know? So it could be of read or write type. Depending on that, you will have to think how to design. So request per second, you can ask, like, interviewer, you can come up directly with this, or you can start with estimate of, okay, how many users are there? How many average requests, like, you think they make every day? And then based on that, you can do all sort of maths, like, divide by, it is 6,400 like seconds in a day. You can come up with that. Other thing is, if you are building all these services like with something like Twitter, like, or Facebook scale, then if you are going through these blogs and you have a rough idea, a rough estimate of what is the request per second we are designing the system, you can just agree to a number and you can go ahead. So that is the request per second we have talked about. Anybody wants to add anything in this?
I think the mean response time, the latency is also important, because Request per second is mostly the throughput that we talk about, and then there's latency.
Latency.
And then we break them down into the percentile calculation. So what is our 60th percentile latency? What is the 95th, 98th, depending on the requirement of the system.
Okay,
What is
98th
the
percentile,
user experience?
99.9, that kind of thing. Yeah, this is good thing to bring. Okay, so now, yes, what about database? You will have, suppose people are uploading images and all. So
Yeah,
how much
storage
data?
is a totally different storage, and then what kind of a storage you need, like relational, non-relational, what are your requirements on that, highly available, highly consistent, and then you move on to the network capacity as well. So what should be the outgoing burst you need per window of your transaction to take care of the data. So for example, if I have a lot of clients that are just posting tweets and I am going to save those tweets in the database. So there's a lot of data coming in every transaction, and I can bear the loss of consistency over here, but I cannot manage to lose any kind of tweet. So I mean, social networks and these kind of applications can be eventually consistent, but availability is very important for them. But when it comes to financial transaction, no, we cannot be eventually consistent. We have to be strictly consistent. And if the availability is not there, it shouldn't be there across. So the faulty transactions cannot even begin.
Right. So when we talk about we are building a system design, we will go through this first, of course, functional requirement, and then these will be our non-functional requirements. And even before we come to capacity estimation, we should have a rough idea which kind of database we are going with, though it may affect your capacity may affect other, but you kind of make that decision earlier and then come to this. It's a good idea. Do you agree?
Yes, the right
Because
direction to begin with, yes.
yeah, so then capacity estimation, as we said, okay, what is your request per second you can handle, read write ratio, then okay, how much data you want to keep in your system, how long you want to keep it also. There are a lot of requirements now even for databases, like when you put the data in the storage, you might have heard about encryption at rest, whether for security reason do you want to keep that or not. Then you may have to replicate the data. So if you have for example the replication factor of 3, then that may change your estimate, right? So
Yes, and then we have to think about the cold storage for the long run. So for example, after 5 years, all the data which used to be backed up on the tape drives, now they go in the
yeah,
cold storage with Amazon Glacier, etc. These kind of services.
right, good idea. So after a certain time, it will automatically gets backed up to that kind of drives, or if you have to write a job for that, you can handle that. Good to bring that out. So again, then network. How does network throughput affects us? Can somebody talk about it?
Yeah, sure. So it actually, two things, latency and throughput, they dictate the quality of service. So for example, throughput would mean, to understand it for everyone, to make it very simple, it's like how many cars can go in parallel on a road. So how many lanes you have to go on the road, the bandwidth. That
Yeah,
will be your throughput. How many users can you sustain in one pipe? And then the latency is how fast a car can go from any lane. That will be the latency. And then you calculate the mean latency, and then you give the percentiles based on that. So that's the difference. A lot of newcomers I've observed think that throughput and latency are probably somehow the same thing. That's where the confusion goes. They are orthogonal things, they're different things. They're totally actually different. Yes, they impact each other depending on how you design the system. But when you speak of latency and throughput, you have to design your system for both of them in isolation. An ideal system would have a very nice throughput very small latency, but that's an ideal system. That's where you want to approach. And that's where you make trade-offs in the system. No system is perfect. You always make trade-offs. So
Right.
sometimes you make trade-offs in the storage, sometimes you make trade-off in the latency. So for example, somewhere in the high throughput systems inside Google, they make they measure every request that if the mean 95th percentile of a certain request is actually increasing in the response, so the latency is higher, they start shifting the request to other servers. This is one of the techniques that a lot of people use as well. It can happen because of the garbage collection as well, because garbage collection is a huge factor in the system. And that's what you would have observed if some of you are using Java, maybe. You might have observed that Oracle is introducing new kind of garbage collectors because it has to do with the latency, stop the world collector kind of thing.
Right.
So it depends on us how deep we go. But practically speaking, when you design such systems, you have to consider every single thing.
Right. So for example, suppose I went to a data center and like think about some theoretical like limit. So every data center may have a limit that, okay, this is the throughput they can give you, egress and ingress, right? And suppose you have breached that, like, or at least your system is so famous that that particular data center can't handle, then what do you do?
Then we should have a redundancy in service actually. So if a data center cannot handle such requests, we should have the data center in the other zone where the request goes. It happens during the network meltdown on AWS as well. So if you have a lot of requests coming in and you are in the auto scale, it's transparent for you if you auto scale inside a data center or you go outside a data center. It has to be intelligent. So for example, your cloud provider like AWS or Azure has to be intelligent to keep you geographically close. But if you speak of redundancy as in DR, it has to make sure that you are in a different region because if a fire or earthquake, anything goes down, brings your data center down, your services have to be highly available. So the question that you have asked is more about the availability of a service. And then it also affects the consistency as well, which brings us back somehow to the CAP theorem.
So the thing is like, also, I guess, like if I'm like independent business, for example, and I'm using this cloud service, they may be charging me for this network bandwidth also, right? If I say, hey, I need this much bandwidth. So even for your cost estimation, it may be required, right?
Absolutely. They charge you for the egress traffic. AWS does at least.
Right. So this is also a very important thing. So you will see in a lot of system design, why do we talk about this thing? And let's not go too deep. Yeah, all this, everything we are talking about is going to get very deep. So we'll have to leave things. And somebody wants to talk about CAS a little bit.
About the network bandwidth, is that would mean there's a possible for the bottleneck on the network bandwidth, but like the service is still have a capability to take more requests, right? So the network bandwidth is the one that cause a bottleneck.
Yes, it can cause a bottleneck, especially let's say if you have multiple nodes that talk to each other in your cloud service, but your node has a capacity on a certain threshold for the network. Let's say 10 megabits per second or certain X megabytes per second or bits per second, whatever you calculate. So you will reach this, this capacity on the network throughput very early if you are having a very huge number of incoming requests. So you have to consider that as well, the node specification. So giving you, for example, in AWS, we have like T2 kind of micro instances, which have a lower network burst capacity. And then you have C5 servers as well, which used to be C4 in the early days. So they have a very different network IO capacity. So you make sure that network doesn't become the bottleneck. So yes, you have to calculate this as well.
Also, can I do that? Like say, for example, the request came and I'm serving in 3 data center, for example, like East US, West US, and maybe West Central US, for example. The traffic is too much in East US for some reason, something happened there, like, so I can fail over, or maybe my load balancer, if it's a like weighted load balancer, it can divert some traffic. Suppose my design supports that, like I'm making a lot of assumption, but I can then probably divert that traffic to other data center. Is that feasible?
Yeah, that's also feasible. That will require probably software-based networking, because the early load balancers was quite simple. The weight, I would say, simple load balanced services, round robin kind of. So if you have 3 nodes behind a load balancer, it will do a round robin 1, 2, 3 nodes without worrying about anything. But today you can have a software-defined networking in which you can compose load balancers, which consider the origin, the geographical location of your request. So if your request is coming from EU West, let's say Western region, then you'll probably use your servers located in EU East, if that's the only nearest available service, rather than sending your requests to EU West, let's say. So yes, this is also practically possible.
Yep. So I have used Azure load balancer. Actually, they call it traffic manager. They have this weighted kind of thing, so you can, move things from one region to the other if you are stuck. There's a lot too much load. Let's talk about cache a little bit. Like, what will you estimate in cache? Like, how much you will keep in cache, or how would you determine what to keep, and that then we can move to the next thing.
So,
Sure. So caching, yeah, please go ahead.
Oh, I just want to add, like, caching, generally, if I see caching, I generally go with like something like an 80-20 rule, where 20% of your things represent like 80% of your traffic, because not everything in your database you want to show. Like, think about anything like Amazon.com or any other retailer. Not every product people are purchasing. Like, there are always like top 20% which people are trying to purchase, and that represent 80% of traffic. So if I just go with that rule and keep the 20%, then it will suffice my needs. And then on top of that, there could be other policies I can implement, like this what is called
The LRU, that kind of thing you're talking about.
Yes, least recent used, least frequent used
policy,
and how long it should be remain in the cache. What is called time to live, TTL, time to live. So, yeah, other things which can time to live, and I think other things you mentioned last session also, cache miss.
Yeah.
But I think for now, I think 80-20 rule, policies, and least frequent use or least recent use could be helpful while talking about a caching scenario.
Right. Great. So
actually,
yeah,
there's
all
a
these
couple of
things you
things.
can, yeah.
Yeah, so for example, some data set you cannot cache at all. For example, your users. The customers are trying to log in. You cannot cache any user at all. You can cache their profiles or their user profile object, let's say. But this service cannot hit your caching layer consistently. You know that investing any kind of caching in that will not be worth it. Otherwise, you'll be replicating entire thing in your cache.
Right.
But there are some data sets which you can blindly go ahead and cache. For example, the lookups, country lookups, geographical, kind of lookup tables, etc.
Right.
You can blindly cache those things on the boot up or the restart of the service, of the server, or the outgoing messages of the server when it boots up, or your nodes automatically. There are many ways to cache it up. It's called hot cache, actually. But then there is a middle ground in which, like I mentioned, user profile objects. So all the users who are logged in, you can query their user profiles and then keep it in the cache. But then it goes beyond one level more. For example, if you have a post service which updates your user profile. I'm taking an example of user profile just so that everyone understands as a very simple example. So then you have to make sure that cache invalidation is also in place and it is working fine, because so for example, in an auto scale system, when you have n number of nodes,
Mm-hmm.
You don't know which node will require which copy of user profile. And if it's talking to a central caching server,
Mm-hmm.
it will incur the network IO cost. For example, you might have a Redis cache server as a managed service, but it will incur a network IO cost every
Right.
single time your node goes out to the Redis server to request. But then if you have an in-memory on the node cache, the
Right.
problem is how do you make it distributed? Because you have n number of nodes increasing in, going out, depending on the traffic. And as soon as a new node comes in, if it's in memory, some caching solution has to boot up as well. And when it goes out, the caching solution has to make sure that the replicated copies are enough.
Right.
Yeah. So in that kind of situation, you have to kind of think about it. How much you want to cache, and what do you want to cache exactly, and where do you want to cache it? And then you have eviction policies like LRU, like kind of timeout, like stale copy removal, etc. There are MRU caches, many different policies available.
Yeah, we touched a little bit about this idea, like, a little bit about this aspect in previous session.
Mhm.
So yeah, this is a good point. With this, like, this will be your capacity estimation, and you will have to do it hopefully in 5 minutes, right? So be very aware if you can get a shortcut, like, if you can directly get to the request per second, it's a win-win for you. And probably, like, the interviewer will not be too much bothered like, as you may think. So don't start, like, calculating all those simple math, because you want to get over with this faster so that you can actually focus on building the system. So after this, I think the next thing we can talk about is a little bit about rate limiting. And I will take a break for 2 minutes, and I would really, mm, I will appreciate if you guys can start thinking or talking about rate limiting in the meantime. What does that mean? Like, the scenario is like, a lot of clients are calling your service, and suppose one couple of clients are, like, very chatty, they just keep sending a lot of requests, even, like, like DOS attack has happened, things like that. How would you handle that? It's also a very practical situation. So it's a, like, real time, it happens a lot. I will be back in 2 minutes, and then you guys can talk a little bit, and then I will resume from there.
So I think for API rate limiter, why we need it, I think that is the foremost question. Like, we know we have a load balancer and which can direct requests to different instances, but why we need a rate limiter?
So as Roger mentioned, right, we can have, like, if one client is literally loading the server, then others performance might also affect, or they might not be able to reach the server, like denial of service attack or something, and somebody might be sending malicious requests, I'm thinking.
Yeah, it could be a hacker also, it could be
Right.
just,
Yeah. So can we think about, like, regulating or monitoring the request type or the sources to start, as a startup idea? Like,
Yes, but what would be the properties of the rate limiter? It could be like some threshold value. After that, if you're getting like man requests, you're trying to limit, or you start giving, I forget the response type. What is it? 409? It will say too many
504
requests.
bad gateway, a lot of things. Actually, there are multiple aspects to it. Aspect number one, like you guys correctly identified, it's a cybersecurity threat, DOS or DDoS. Aspect number two is it's a real cost on your infrastructure. So for example, if you are providing a service that's open to the public, any kind of API that collects data from somewhere and then does some kind of algorithm and returns you the result, that's actually a cost on your infrastructure, right?
Yeah.
So you better make sure that you are getting enough number of requests that you can sustain your infrastructure before your infrastructure goes down and it starts giving 5 or 4 bad gateways. That's where you put a rate limit.
Or
There are easy ways these days. Yeah, go ahead.
so or instead of that, it will start scaling really crazy, because these days we are working on with cloud technology, and we
It
can.
depends if you put it on auto scale. So if you say that no, for example, now there are two directions from what you just said. One is if you put your system on auto scale, how fast can your nodes spin up to participate and take care of the load? If your nodes spin up much later than the traffic increases, your system will definitely go down and you will lose some requests in the face of
Yeah.
real requests. Thinking of the opposite example, if you have set yourself on auto scale and you are under a DOS attack, definitely you will end up spending a lot of money for fake requests.
Yes.
So there are certain practical solutions for that. For example, in Azure, AWS, etc. Speaking of AWS, you have WAF service enabled, WAF shield, which actually intelligently identifies if the same request is coming from a certain geographical region based on the request origin and IP, etc. It blocks that request on a certain threshold. Otherwise, it allows the clients to pass the request through the infrastructure.
Yes.
Yeah, there's API gateway as well, but that's far more expensive, practically speaking.
Okay, so I guess you guys already talked about why we need it. Is that clear already?
Yeah.
Okay, great. And so yeah, that's the purpose. And then like, how would we do it? Which kind of algorithm we will implement? What is the benefit? Okay, normal DOS, maybe you can handle. Can we handle distributed DOS or not? That are a lot of questions. And if we design a proper rate limiter, then that will be again a question in itself. But yeah, just give a basic idea, like something very basic, like how the request will flow. Suppose a client made a request. So before serving the request, should I look at my rate limiter, like whether he has breached the limit or not, and then allow it?
Actually, rate limiter sits between you and the client. So if the rate is exceeding, the request should not even end up in the server itself, infrastructure itself.
So, okay, let me actually call. So this is, let's call it load balancer. That's right. So I will still get it. And my service is, you are right. Just to make it clear, let me make it here. So before taking a, so who will call, who will call rate limiter? So here is load balancer. Request came. And suppose if there was no rate limiter, then load balancer would have sent it to this guy. And this guy would have checked the database, did all the business logic, other services we don't want to talk about. It would have returned the response. Now I am including a rate limiter in my system. So how the order should be? Should it be that, okay, don't do all this expensive thing before I confirm, this thing, whether rate limiter allows me to do or not? Can I design like that?
Well, of course, you can design it this way, but this will be adding complexity unnecessarily in the system. If I would design it, let's say I would put it like, if I'm using the API gateway will address it for me before even coming to my internal LB.
But we just talked that API gateway we won't use, right? I think 5 minutes ago, I think I heard that.
Yeah, and on the other option, I will consider using WAF as a service on, let's say, speaking of AWS and Azure, there must be another service for that. So this, before the traffic enters on top of my LB, WAF actually makes sure that the traffic is actually genuine. It's not being originated as a DOS attack or something.
Right.
It's not strictly speaking rate limiting, but it does the purpose, it serves the purpose.
So some intelligence could be here, right? I think I will come to that a little bit today, hopefully, if we have time. Some intelligence, if it is there, it can determine, hey, this is just return, there are too many requests from this guy, just return 429 or something. Also, yeah, what does 429 means? I just want to make sure because maybe not everybody has used it. So anyone else?
It's simply too many requests, you know. You can do the I'm a kettle as well. I mean, HTTP responses. There are many funny responses.
Yeah, too many requests and then call later, things like that you can do. Okay, so rate limiter design will have a couple of strategies and we will not go into it because we have other things to cover. But you can read about like sliding window, token buckets, things like that. I will just write it down. I'm not even touching the surface, but like whatever coming to my mind, I'm just writing.
So are these rate limiting services aware of the kind of services they are shielding, or they are just agnostic? Like, do they have any intelligence that they want to limit the rate differently for, let's say, a storage versus a database?
They are agnostic. They just work on the target group mapping. So a traffic is supposed to end up at certain endpoint / resource / service, HTTP get post, etc.
I see.
So you just need to define those mappings for the rate limiter and what kind of traffic you want to put a threshold on. They have no idea if this service will end up hitting a database or a cache or S3, whatever.
I see. So they operate at like, do they operate at a specific network layer, or still an app?
Take it as your web server, you know, HTTP web server.
I see.
Yeah, so in real system, like, you know, you may have some configuration. Suppose some client, maybe they are paid client, and you want to allow like, you know, different premium scale, like, you know, that for free clients, you are allowing them to make say 10 requests per second. But there are some premium clients, they are paying you and you are allowing them like, you know, 200 requests per second. For example, if you can scale, then your rate limiter, you can have a like, you know, configurable policy which can change that limit into the rate limiter, maybe at the real time, and then you will make that change. So like, you know, depending on the different client, you have different rate limiters. So that is one way to like, you know, solve that. So with that, I think we have just touched purpose of rate limiting and possible ways we can do it. Now I want to go to before starting and replication because that's complex. Let me try to go to some.
Could we just quickly talking about the sliding window or token bucket? Not go in depth, but you know, the high level.
So sliding window is like you use in like algorithm that in, okay, you can make 5 requests in like 1 minute, right? So, or maybe say you can make 15 requests in 3 minutes. So your window should be that 3 minute, right? And then you need to keep count, like how many actually requests you made in last 3 minutes. So that would be the idea of sliding window. Is that clear?
Yes.
And the token bucket could be like, not all requests could be equally costly, right? Maybe some request is very like, you know, load intensive, maybe. So you can allow a certain like, you know, token, like suppose like one call is equivalent to 5 read, one write call is suppose equivalent to 5 read calls. I'm just giving you a vague example. So you can think like one write is equivalent to 5 tokens if one read is one token, right?
Okay.
So if you think like that, then you basically are leveraging that piece of information that like don't allow too many like writes because we can't handle, or maybe it's costly. So that can like, you know, just go and read about it.
Yeah.
It will
So
have better example.
It's not limit on time, right? It only limit on the number of requests. For in case of the token bucket.
Yeah, it will have other things also, not just request. How costly is the request, right?
And one more point on both of these is all the requests in that case is assumed to be going through one server, which may not be ideal for a distributed system. So there is some variation on this, which I think is good to read about.
Right. But you can also make your rate limiting system, like, use a distributed cache or something, right? Can we do that? Like, which will actually, I have seen some very bad implementation where even they read from database, but I don't know, in practical scenario, somehow you need to gather information across the cluster, right? You can make a node level throughput for sure. Yeah, if you can handle, but yeah, a lot of design choices we can make around that. So thanks for adding that. Was it Samir?
No, that's Vijay.
Vijay. Okay, thanks guys. So now let's talk about some scenario, because I like you guys are answering all the questions. So it's very exciting, at least for me. If I tell you about the topic, then you are biased already. So, and then maybe you will come up with a solution which I don't know. So I want to also learn that solution. That's a very good session. Now, my scenario is this thing. So what I'm interested now is that, okay, there are some bad URLs, right? That is one use case. Or things like, I want to, for example, Google Chrome has bad URL. They will tell you don't even go there without actually going there, right? Then other thing could be like your load balancer is telling you this IP address is, I should not allow these blacklisted IP addresses to even make further call. That is one scenario I'm talking about. So how would you go about doing that? So you have couple of things, couple of IP address, for example, and they are blacklisted. So the idea is, if there is a call, this is a very simple scenario, don't allow a call to be made. This is your load balancers, for example. Any idea? Just think like what will be the brute force approach?
I guess distributed cache, or
Okay.
at least some cache, could be harboring all the blacklisted IPs, and before load balancer
So
forward the request.
somewhere I am writing that IP, and then I am writing whether it is blacklisted or not, right? Or maybe a set or something, right?
Yeah, only blacklisted IP.
Just IP addresses. Okay, so I can have these much IP addresses. So okay, for example, if I have this use case is not that great, but suppose I am writing, say, a spell checker. So I want to load the entire dictionary in my cache or somewhere, and somebody when writes something, I will tell that, hey, is the spelling is right or wrong? If the, for example, if the spelling is in the dictionary, then I can say that, okay, this is right. If it is not, then I'm saying it's wrong. Check your spelling, for example. So in a dictionary, you can have a lot of words, right?
Yeah.
And so one idea which we are talking about currently is have a hash set or hash map kind of structure, load all this thing in your memory, right?
It will go really big.
And then just check it when something happens, say it is there or not, and just return it. However, you talk to your manager or something, and we have made that choice that it's okay to be bad at times, like okay, it not has to be perfect. For example, you can have some like some inaccuracy. Will that change your solution?
Yeah, that seems to happen to Google, right? If you enter something, like it may not immediately suggest that's the right spelling, but then come back, oh, did you mean that? Which likely means there's a response coming back from the server, which
Okay.
did a more thorough check of the query string. So yes, should change the solution. And you may have a smaller hash set of frequently used words in the
So there,
language.
I think there's one data structure called Bloom filters, which can do a reduced hash set and give such properties.
Yes.
Okay, so it was a seam, right?
Yeah.
Great. So that's what I wanted to cover next. So I like this way to go, when you can guess and then we talk about it a little bit briefly. So, and we'll see how it will work briefly.
So I think Bloom filter does not guarantee something is there in the hash sec, but it guarantees something is not there.
Yeah. So Bloom filter, when you have very less space and you can say that false negative is not possible. I can't write again. Okay, false negative. If I am saying something is not there, this is right. False negative, not possible. But I am saying that, hey, this is in your set, then it may not be there. So false positive is possible. This is possible. And how does that work is not very complex, so we can go there. So for example, like just to understand, let's have something like array, bit array. And let's call there is, you have a couple of hash functions. For a simplicity, let's just take two hash functions, f1 and f2. F1 and f2. Yeah. So now take any word and hash it to one of the bucket. For example, my word was, for example, cat. And it landed into, so my bucket is 0, 1, 2, 3, 4, 5, 6. It will not be that small, but it will be just for demonstration. It is telling me that, okay, the hash function is going to this bucket, like say 4. F2 for cat is saying that, okay, it should be in 1. All right. So what you do, you will turn on that. So 1 is turned on in 4 and 1 is turned on in 1. So you put that thing like cat is possible. Now let's go, let's call F1 on dog, for example. F1 on dog, give me something between 0 to 5, 0 to 6, anything.
6.
6, okay. And F2 of dog?
0.
0. Don't you want some collision? You are giving too easy, but we'll change it. Okay. For now, let's do it. 1, 1. Oh, come on. All right. So this is my Bloom filter looking currently. So now, suppose I'm checking whether dog is there or not. So this was the write operation I did already. Now I'm doing the read operation. So I will again go through the same hash function and I will check whether 6-bit is set. So it will get yes, 6 is set. What about F2? F2 of dog is 0 and 0 is also set. So if both are set, then what we are saying that dog is in the Bloom filter. So we are saying that yes, dog is in. All right. Suppose I am looking for something mouse or something. So your F1 may map to, say, give me anything, basically. F1 of mouse. Anyone?
One.
F1 of mouse is 1. Okay. Is equal to 1. F2 of mouse is
Equal to 1, 2.
1, 2. Okay.
No, equal to 1.
F2 is also 1.
Yes.
So you have to choose your function, which is not like that. So that will be the restriction you have. You will not choose a function which clash among themselves. So you may choose a different seed to do that also. So it's not a good actually hash function. So let me demonstrate. We will talk about. So let's go with this. So F1 of mouse was 1, F2 of mouse was 2. Then what conclusion you will make? That 1 was set, but 2 was not set. Okay. So based on that, you can definitely say that mouse is not in the bit, like in this filter. Problem could have happened here. Like suppose F1 of dog was 6 and F2 of dog was 1, for example. Or actually, what I want to see a clashing scenario where you will actually report that it is there when it is not. So, okay, yeah, in this example itself, actually, F2 of mouse, let's not make it 1, but let's make it 4. Not 4, let's make it 6. That can easily happen. Now what we are reporting. So 1 is set. 1 is definitely set and 6 is also set, right? 1 was set by cat here and 6 was set by dog. So now my bit, this filter will tell that mouse exists, though it doesn't. So that is this false positive. This is that when it will tell you that something exists, it doesn't. It's possible that it may not.
Right.
So if you can live with that, some probabilistic, cases, all you realize on this, then it is a good data structure, especially for streaming scenarios when you don't have time to make expensive calls and you have very less space. Then think about it. You will have how much saving you can do. Like in hash set, you will have filled all your words in a hash set. Each word, I think by on average, suppose it was taking 32-bit. It could be more, but just take some average. Here you have a fixed site of bit array, could be couple of bytes, and you can load it, and then you can just use it for use cases. So that's the brief intro. There are some issues also. We can talk about that. Or the issue is now suppose you want to continue changing it, for example. Can you delete from this or not? So that could be challenging. And there are some implementation which allows that. So you should actually read about Bloom filter use cases, but this is the basics. Is that clear?
Yeah.
Great. Okay.
Hey, Roger, can you take a not possible scenario, false negative?
False negative, not possible.
So right now, the situation which we did for the mouse was a false positive. Yeah. It is not there, but our system told it is there.
Yeah.
But so Bloom filter tells if something is not there, it will say it is not there.
Right.
So I was thinking how I can say okay, which could be false positive, what thing I'm looking for, it should say. Or it is always a combination of false negative and false positives.
No, so before I changed this value, I briefly demoed that. This value was, I think, something else in the beginning, but yeah, it was 2, right? So at that point of time, I was telling that, okay, if it is telling me that it is not there, it is definitely not, because if it was there, I would have set that bit anyway, right?
Mm-hmm.
So that's why I'm confident. I'm not confident for the positive case because of hash collision, right?
Mm-hmm.
Because there could be collision and someone else contributed to that bit, and that's why that false positive was possible.
So when it was F2 mouses 2, so it's guarantee it is not there. But now here the guarantee is not there. Okay, got it.
Exactly. Yeah. All right. So
For the Bloom filter, let's say, suppose you have, initially you have only 6 or 7 bit right here. And can you expand it later to, let's say, 16 bit? Or once you select it, and then it always stay at the same size?
it will be challenging just because now you have to rehash everything which was there, right? So yeah, if you can bootstrap your process before you start actually serving the request, you can, like, go through all the possible, like, words in the beginning and you pre-fill it, then it's possible. But dynamically, it will be, I don't think there is an easy way to expand it.
Actually, I'll add one more point. In Bloom filter, the main thing, what it is to choose the number of bucket, or in this example, the number of bits
Yes.
you need in order to set. And the second is the functions, number of functions you need to identify, because the bit array is needed to reduce the size. That's helping you reduce the size. And function are helping you to kind of provide the uniqueness across all your user, so that you're setting those particular ones. So those are 2 things I think helps you to design your Bloom filter correctly.
Right. Do I agree?
Practically, how many functions are typically used? Let's say for English dictionary.
I think you can, it depends, but like 3 is a good choice to start with. And then also depends how big your data set is. So that will tell you what is a good value of your bit set size, like how many bits you want to keep it there. Actually, there is some mathematical equation which will give you, if you are ready
Enough
for like
uniqueness.
0.001% of
Yeah.
like error, then choose this value. Things
So
like that.
for services, let's say, can they be harboring different Bloom filters based on the different kind of, let's say, languages that are being? So
Also,
take the example of spelling, right? So Google could be harboring different Bloom filters for different languages.
for different languages. From language, what do you mean here?
Like English or Chinese or some other language.
Yeah, it's possible. It's possible, but maybe not necessary. I don't know.
I think it's a good question. Let's say these languages are represented by Unicode character set.
Yeah.
So it all boils to the character set that you support. So let's say for this question, if it's Unicode, it doesn't matter which language you use.
Oh, because false positive is tolerated. Okay.
One good example on this false positive and this false negative would be, let's say if you hash the word rabbit, it gives you value 4. So this one is a kind of false positive, because if you see 4, there is a bit already up on 4, but rabbit doesn't exist in our data set. So then you will have to go in and calculate the equals as well. So if you go on 4, do you really have rabbit or not? Which will turn out to be false in our data set. But if, because of your hash function, hashing rabbit multiple times would have given you 7, you would have been definitely sure that rabbit does not exist in this data set. I think someone else also asked this question a while ago. This is a simple, straightforward example for false negative, false positive.
Right. So yeah, go ahead, dig it. We just touched it. We didn't even scratch the surface, as I talked in the beginning. So let's solve another scenario. Are we ready for that? another problem. Okay, this time think about it. So I want to find, like, suppose there is YouTube or something. I have a like big video service and I want a view count, like view count for a video. And I have, say, I don't know how many, maybe 4 billion or whatever, like too many videos. I have many videos, like 4 billion videos, and I want view count for the videos. So yeah, please go ahead with brute force if you want, or if you have an idea for, again, I want to reduce space, same concept. And I'm also ready to take some, like, probabilistically, like, some error is fine for me.
Roger, so is the question about finding a view count for a video, or like you want to have a list of like, or I wasn't sure exactly what the input is.
So input could be like video ID.
Okay, okay. For a particular video, we want a view count.
Right, right.
Okay.
And you can have such 4 billion videos, for example, like too many videos.
Right, right.
Yeah, brute force, please start with brute force. I need water, I will grab it, and then I will come back in 1 minute.
So here it seems like for every video, we need to get how many times it has been watched and then return it. But
Right, yeah.
but there should be more to that. If same person is looking at video couple of times, then it should still account one. I think there are some algorithms like Google also does, like from same IP or same user. If the user is watching multiple times, then they don't keep on adding the count.
Another problem is to how to estimate or synchronize all the view count in one aggregated view. Because
yeah, I
let's
was
say,
thinking, yeah, that's how I was looking at the question, that, like my service might be computing the view count in a certain way. Like Asim, you were saying, maybe it's, counting it as one for the same user. But is the question more about, like, depending on howsoever your service is, coming up with the view count, we want to fetch the aggregated one.
So we are assuming that is it something like we are assuming that our video is distributed in different zones, and based on that, every zone I have to aggregate.
Correct.
But still I can, but it still can put in one table and get the entire count at once.
I was thinking of, sorry, go ahead.
We distribute, but metadata could be at one single source.
Yeah, can we think of it as in terms of, having the view counts or having the videos on multiple servers, and then each of them having their own aggregated count, something around like the MapReduce style, right? Each will have its own aggregated one, and then we'll, have a global one. And for the even computing the local aggregates, right? Each of the server can be having a huge, that view count database sort of thing, or list, as simple as that. Then maybe an idea around how do you efficiently aggregate stuff, right? It can be about, clustering, all the requests that are coming in for a particular view ID, or, whatever criteria we want to use. Because if we cluster, then we can do aggregation pretty quickly compared to if they're all scattered. So, yeah, those.
Okay, I think Roger is back.
Yeah, you guys can continue, but I'm just estimating like how much is, suppose the basic thing is like I can put like, a key value pair, which will have like
Yeah,
the video ID and the value will be the count, like,
right.
right? So how much memory we are going to incur? So 4 byte for one, like 4 byte is just key and 4 byte is value also. So just for key, I will incur 4 byte into, so 2 to the power 2 into, there are such 4 into 2 to the power 30. So 4 into 2 to the power 30. So 16. So basically 16 GB just for my key. By the way, guys, if you are doing estimate, just remember this thing. This helps a lot, like to do some faster calculation. Like 2 to the power 10 is equivalent to 10 to the power 3. So I'm just using that thing here, right? So 10 to the power 5. So 16 GB is key and 16 GB is your value. So now if I just keep it somewhere, I have to have 32 GB storage, right? I'm assuming 32-bit for like int key and values, both are taking that much. But yeah, the long story short, it's too much space and I want to reduce it. And again, as I talked, like, we are okay not to give the exact, like, exact count. It's like, estimated count is okay.
There is a, again, probabilistic data structure count means sketch. Probably you're alluding towards that.
Yeah, I'm leaning towards that. So I'm really happy that somebody talked about it before I came up. So we will learn about it now. Hopefully then we will remember. All right. So the database, so the algo is called count min sketch. Again, streaming, you can use it, but yeah, for detail, feel free to look at count min sketch. So what is min, what is a sketch, and what is count here? Okay, so anytime you want magic in life, you have to depend on hash function because it solves all the problems somehow. So idea is, now there are a lot of videos, right? Suppose we have a couple of hash functions and we will again, like, let the video ID go through these hash functions like we did last time. And then we will plot, like, we will have a certain range of values, like, how many values these hash function can, like, have. So let me try to draw a sketch actually, something like this, for example. Okay, let's have 3. Okay, and whatever has been like 0, 1, 2, 3. So 0, 1, 2, 3, 4, 5. This is F1, this is F2, this is F3. So we have chosen 3 hash function. Now suppose one video ID came and let's call this video ID was, for simplicity, let's call it 1, right? Now you guys can suggest me value for F1. So F11, sorry. I want value for F21 and I also want value for F31. Give something, we will see how it will work. At least, best case. So values should be in this range, 0 to 5. Okay, nobody tells me, then I can take my own example. Anything.
0, 1, 2. Simple.
Okay, simple. Okay. 0, 1, 2. All right, so 0, 1, 2. So now value for 0, I will make this guy 1. So for F2, it's 1. So this is how I'm sketching. See, this is the sketch part of this strategy, like, what we are going through. Now, let's put another video. Let's do like video ID is supposed to. So for that, let's do the same thing. 1, 2, F2, 2, and F3, 2, F3, 2. Don't tell me 0, 1, 2. That is too bad. Like if for the different ID, it will all go to the same bucket. It's not a good hash function.
1, 3, 4.
1, 3, 4. Okay. 1, 3, 4. 1, 3, 4. So let's sketch this guy. So F1, 2 should become 1. F2, 2 should become 3. So sorry, 1, because that's 1 time. So F2, 2 is 3. So let's make this guy 1. And F3, 2 is 4. So 4 will become 1. Okay, now let's do one thing. Let's play one of this video one more time. That's the basic use case, so that we will have a different count.
So F1 of 2 is 1, right?
F1 of 2 is 1. So F1 of, okay, yes, thanks. Did I make any other mistake? Yeah, just make sure, otherwise I can make wrong calculation. So F2 is 3, F3 is 4. Okay, so now let's play this video one more time. So we already know the count for F1, F2, F3. So, okay, so we'll go to 0, we'll increase the count. So it was 1, so I will make this 1 to 2. Sounds good?
Yeah.
So I am making it 2. F2, 1 is 1. So I will look into F2, 1 and I will increase the count by 1. So there was 1 already. So let's make it 2. And F3, 1 was 2. That will also become 2. So that's fine. I was thinking, okay, so we had no collision, right? It's not fun, by the way. If there is no collision, I can easily prove this thing. Because see, all the values are unique, right? Or I made a wrong sketch. So F2, 1 had no collision. F2, 2 has no collision, right? F3, 2 had no collision.
Yeah, there's no collision.
I mean, we can make one of them same as previous.
Yeah, let's collide one at least. So let's collide, for example. That will be a better case. So let's collide F2, 2 to something, maybe 1. F2, 2 is 1, for example. And make F1, 2 to something totally different. So F1, 1, F1, 2 is basically like, let's call it 5. Okay, so how will it change? So F2, 2, so F2, 2 is 1. Now this will become 3, right? And one more thing, what I made F1, 2 to 5. So F1, 5 will be set 1. And probably I had set 1, so I will just erase this guy. Okay, so looks better now. Okay, so now let's calculate the count for F1. So we have our sketch ready. We'll again go through this function. So we'll again go through this function. So let's take a look at value at 0. So value at 0 is 2. For 1, I'm checking what is the count for video 1. Value for 2, f21 is 3. f31 is 2. So what we do, we take the minimum of this. So what we are saying that the count is 2. What we are saying that video 1 was played for like 2 times, and that's the min part of it. You sketched it, you updated the counts on the sketch, and you are taking the minimum out of all the possible like hashes. And why it works? Because like you may have collision, right? You may have collisions, so you want to take the lower value. So I know that if these guys were 2 and other was 3, I can guess, okay, this was due to a collision from some other hash function. If you run the same thing for 2, you will again get the same value. You will have 1, 1, 2, and minimum will be 1. So we can say that video 2 was run for just 1 time. Is it a little bit clear why it will work?
Yeah.
Okay.
So I don't see why there could be an error in there. I mean, what? Yeah, if we do that, could you provide a case that could be an error? I mean, the count could be different.
Yeah, when the count could be different, right? You're asking that, right? So suppose like I did run multiple videos, video 4, 5, 6, up to 10 or something. Now, even though they didn't actually had value like same values, but they can independently change 1 bit at least. It's possible, right? So suppose for video 4, I am updating like 3 values. So I will make this guy 3. I will make suppose this guy 1, right? I'm not fully colliding, but I'm just showing you. And maybe this value was also 1. Okay. Video 5 came. So video 5 also didn't like change everything. It just changed this value to 3, this value to 2, and this value to 1. And sorry, this value to 2, or maybe this value to 2, doesn't matter. But already at this point of time, if you look at your value for video count 1, see, everything is now 3. But video 1 only did run for 2 times, if you remember. So you can get overcount. It will never undercount.
Okay, yeah. It's overcount, but never undercount.
Yeah. So that is one important thing to keep in mind, that if you're going with this, you may overcount things, but never undercount. And if you think about how much space we will have for this thing, maybe a couple of kilobyte actually. So suppose you can have like multiple hash functions. So all your hash function will be the matrix like row, right? And you can have like for less errors and less collisions, maybe 1,000 such. Each row have 1,000 columns. So you will have 1,000 into 8 byte. So basically you can have 8 kilobyte, and you will have a very, very good, like, relatively good, like storage, and very less error, not very much. So this is used a lot. Go and read about it.
So
Why?
1,000.
Yeah, why?
1,000 is
How?
what?
Go ahead.
So I think 1,000 is what, is it like a representation of the 4 billion videos? Like narrowing it down.
Sorry, what was the question? I
So what
missed.
is the 1,000 here? The different hash values.
Oh, so what I said, I just showed, for example, that this is 0 to 5, but suppose all these 8 hash functions, like currently we just took 3, right?
The range of values that hash function can produce.
Yeah,
From
so
0 to
you are
1,000.
having 8 hash functions, and the range of values they have, like, 0 to 1,000 or 0 to 999. So, and again, it's mathematical. There is a formula how much error you can get. So take a look at the pros and cons, and it can solve other problems also, like what is the trend, like, which video is being watched, or what is the trend of anything. Wherever you want count, you can think about it, at least consider it, especially in streaming scenarios where you don't need the exact value but good enough value.
So for more accuracy, is it to add more hash functions?
Yes, for more accuracy you can do that. Plus, for overall, like, you guys have heard about lambda architecture a little bit. Like if you want a exact count, you can have a batch processing system which can run on some of the previous, like, old data, and it will give you the exact result for that. And you can have a, like, streaming scenarios, so current value which could be estimated, but eventually you will get a right value. So you can take a look how we can use both. Does that give you some useful information?
Yes, yeah. My other series of questions would be, how are these, like in a distributed setup, who's maintaining this in memory? How is this memory being seeded initially when the system boots up?
Yeah, it's a good question. So I have also this kind of question, and I think if you are using maybe Redis or something, they may have this already. But yeah, take a look. Like, there are some inbuilt system which can do this for you.
If you use Redis, you can use your custom serializers to store the data in the way you want to. Otherwise, Redis is famous as a data structures server. So it supports a variety of data structures. Going to the previous question, you have alternatives. If you just want to change the choice of data structure, the other one is hyperlog. It's even more compressed, but the error percentage increases to generally 3% from 1%. And this one, you have 1% error of false negatives.
So actually, so you talked something which was the next thing. So yes, I have no scenarios, but the thing was, we'll just briefly write it so people can actually go and research, and it is more mathematical. So I can't explain here. I will need to myself understand, play with it, and then I can explain someday maybe. But the hyperlog. So currently we are just doing count, right? Now your use case is how many unique users, suppose, at any point of time is visiting your website, like for Facebook or something. So that unique calculation, you can use hyperlog, count distinct elements, and it will also have some probabilistic error, which can be reduced, and it also takes very less space. So look at hyperlog, and your use case is basically count distinct elements. And it is more mathematical. It has a lot of probability theory going on, like, how they, like, derive this formula, and again, very space efficient. So take a look. I will not go into this because I myself haven't, gone through it, rather than, like, I just browsed it. So please go yourself. All right. So with this, what can we talk next? Next, I think I like scenarios because you guys are solving a lot of problems without me going, so that's fun. Let's not go into the theory because hopefully this is more entertaining. Now, suppose I have some value like some value in my node. Like node means like, it could be database. Like, I have a lot of videos stored here and I want to like, replicate or copy it to many servers, not just 1, 2, 3. Suppose a lot of servers. I want to copy all of this here. And this is a like huge data set. And of course you will have network bandwidth, which will limit how much you can copy. So please think about it. Give me some approach, some ideas. How would you go about doing that? Suppose let's call it like something like 50 GB.
Yeah, so one idea I was thinking is that if we go with this one server trying to replicate to these multiple, like you mentioned, there would be bottlenecks, right, in terms of network and stuff. So if we can, since we have to copy this same content to all these servers, can sort of crowdsource it, right? So this copies to, let's say, the first 3, and then we'll kind of let them copy to the other ones, like sort of have parallelism there.
Okay.
That way, rather than putting the load on one, we are actually, spreading it out.
Are you talking about something like this?
Yeah, we can look at it that way.
Kind of, right?
Yeah.
So yeah, yes, I think either I'm very good at giving the scenarios or you guys are pretty good at solving it. So
Is it a
go ahead.
Oh, it's okay. Is it like a read heavy load or write heavy load? Does that matter?
Yeah, it's not for this thing. It doesn't matter what I want. Like, I want this to be done as soon as possible. I want this thing to replicate as soon as possible, this value. Somehow like one basic way is, okay, you have a network throughput. So you will put like, data here first, then you will go put data here. And that's how like you will entirely copy, like, depending on the throughput, it will take some time. So the idea which what DP suggested was probably chunk this, right? Chunk this in a smaller, like, bytes, like a smaller things. You copy it here, and let me erase the other things. Okay, you copied it here, and then you will copy another chunk maybe next time here. But suppose in that instant of time, T1, when we were copying, so T2, we wrote small section, like, instead of 5 GB, suppose we have 5 MB. We have so many 5 MB data we are writing here. In this case, this guy can actually go and talk to his neighbor, or maybe this neighbor will talk and get data from him, this guy. So now if you see, like in the same T2 time, now we have more data being shared. In the T3 time, when like, this guy will go, maybe it will add data somewhere else. Now this is also a source, this is also a source, and this data can get replicated to other places, right? This can get replicated here. So this is the idea, because now we are parallelizing that, and this will happen very fast. And this is exactly like how Corona is being spreaded nowadays. Like, everybody is contributing, right?
Is
So
it a, yeah, is this something similar to the gossip
exactly,
that Amazon Aurora uses?
yes. So this is gossip now, because now these guys have to coordinate among each other, like how, like which data who has, and like, somebody will say, hey, actually, by the way, you don't have this, but this other guy has it. You can have it, like, store this information in a distributed hash table or something, where people can say which data they are missing, and they can go and talk to that server. So this will get replicated, like, really fast way. So that is, like, in some design scenario you may come across this problem. So I thought just I will mention briefly. And good answer.
So this related to consistency, right?
Consistency in terms of what?
Because let's say it replicate, but at certain time, some node might not have a data.
Yeah.
Might not have up-to-date data.
Right. Oh, they may not have up-to-date data, you are saying.
Yeah.
But yes, at least in this particular use case, I was not thinking that this is changing, right? I thought everything is here. And when this guy will have whole entire chunk, then it will update its distributed hash table. You can have an entry for all the nodes and which chunk it has. So you can have node and list of chunk as a value. Okay, I have 1, I have 5, I have 6, something like that. You can create it, like, this kind of mapping. That is one implementation. There could be more, but when somebody writes it that I have this, he makes sure that he actually has it. And then if somebody goes and take a look into this server and can't communicate, then it will go and talk to someone else, because yes, there could be network partition here. So eventually they all will get data. Sounds good?
So I have a question.
Yeah.
So all the nodes, they need to have all the chunks, like, or they can have partial chunk in them. When someone is reading, they will be like communicating to the central server how many chunks are there, and then combining them on the fly.
Right. So that information, like, could be shared, and people, like, these guys will know when they need to stop, like, they will know everything is there. Like, what is this service? The video, like, where you share the videos, or even any books or anything. I don't know, what is that called? P2P system. It's a very interesting P2P system. I forgot. It does the same thing.
Torrent.
Exactly, torrent. Yeah, I wanted to mention that.
Okay.
Torrent. So maybe you can share something which will tell, okay, do I have the entire data or not? Am I missing something? So that could be shared, maybe with checksum or something. Sounds okay?
Yeah, sounds good.
All right. So now what can we do? Okay. We can go to amazing world of databases. If we have time, we have, I don't know, but let's do it fast. Somebody wants to talk about like sharding, replication. That is the next two things I had in my mind. I mean, that's it. And then we will finish it. So we can start with, when do we need sharding and what does that mean? And by the way, guys, all this thing is like, it's like distributed system. People do PhD just on one, like, one of these things. So it can go too much in depth. So just we will touch it, sharding, and then we will talk about a little bit about replication. Yeah, which we just also looked at a little bit in a different way, but maybe. So sharding, let's talk about what does that mean for a database to get sharded. Anyone wants to talk? Okay.
I guess, sorry.
Yeah, go ahead.
I was thinking like probably when we are going with horizontal scaling, right,
Mm-hmm.
and we want to distribute our, let's say you have 1,000, very simple thing, 1,000 or like take any number, you want
Mm-hmm.
to distribute your data set across these multiple nodes.
Mm-hmm.
So that's the idea, right?
Right,
So
right,
you kind of split your actual data set and put a chunk of it on one and so on.
right. So what you are saying, like, okay, if there was data, we can't hold them, and
Yeah,
we will have a smaller such, like, other databases,
right.
and we can just have data distributed there.
Yeah,
So you can call it horizontal partitioning, right?
right.
Okay, yeah, that's one good approach. Anybody has to say anything about that?
Actually, we can partition in the same database. So she say we partition into like the 3 instance of the database, but the same database we still can have a sorting the data into the multiple table.
Right, right. Yeah, that's what I meant. Like the same. Oh, you're saying the same database into multiple tables.
Yes.
Right. Okay.
Right, but is that a good approach? Can you always do that? Like, is database, does single database has limit or not?
If the single database, if currently we don't have a lot of data, we can partition it the same. But in the future, if we know the data will be growing, so
Mm-hmm.
we will replicate that one, or we can scale into another instance of the database. But from beginning, we can sorting in the same database.
So yeah, I mean that's a good way, like step-wise you can do that. Sounds good. And that's another approach. And also like you have videos, that kind of thing, you can move it to maybe just that part you can move it to another
Yeah.
database. Like so yeah, we can do that. Anything, any problem? Can we still get into the same problem? Eventually, still that is.
The problem is how we can sorting the data. Maybe, for example, we can sorting data by the region or something.
Mm-hmm.
But in the future, like New York, we have a lot of requests come to the New York. So it's
Yeah.
for the partition. That means a lot of requests come to that region. So that means have a problem because it's made for the unbalanced. That means a lot of the region don't have a lot of the request coming, but the New York have a lot of the people over there. So that means have a lot of requests to that region. So that means they make for the unbalanced starting the data.
Yeah, the skew would be an issue, right?
Yeah.
Yeah.
Right. Did someone like last year had this thing going on where they may have data in US and they had to move their data to Europe because that was required? Okay, I am surprised nobody.
Oh, you're talking about the regulation stuff. Like,
Right, right. So sometimes like it may not be just a scale, but some other reasons when you have to have like you have to put the database local to the place where it belongs
yeah.
to. So there is another aspect. Okay, so somebody like, okay, suppose I did that, and we can continue going into that, like that there was a hot partition, like some tenant has most of the calls, for example, or some customer has too many writes going or too many reads going on. So how do we handle that hot partitioning thing? Like now, suppose this customer was part of this database, for example, DB1, and you see like 60% of the calls from that guy is affecting other customers because now database is like like really hot all the time. So one partitioning strategy probably suppose you applied was like, you generated a partition ID based on you can have like a hashing function, consistent hashing, different ways, but still you may get into this problem, right? Hot partitioning problem. So anybody wants to talk a little bit? How would you handle that?
Can we consider scaling here, like auto scaling in terms of whichever based on the traffic pattern?
Based on the traffic pattern.
Like if one partition is being uh, targeted or like is experiencing heavy load, then can we think about scaling that one and not the others?
Yeah, that's possible.
Yep.
So
So for example, we have a tree instance of the database. So we can write a hash function like you mentioned about. And then when a request coming by a data on the request, we can use the hash function to decide the which database we will say data or we will retrieve data. And in the future, if have a lot of data, we can add more database, and it's make a problem about like we need to change about our hash function, right? So we can solve it about by using the consistent hashing.
yeah, we solved it by consistent hashing. The problem we are now stuck in is a little bit that we hashed. So a particular tenant gets hashed to this particular, say like database or like, instance of database. And, but these guys are underutilized. I'm just throwing a scenario. You are using suppose some cloud service, maybe document DB or like Cosmos DB, Dynamo DB. They are charging you for overall throughput, right? But they may charge you, take a look, like not like if they are saying that I will give you this much output, like throughput, that doesn't mean that it's infinitely scalable. There will be a limit when you will be forced to, they will tell you that, hey, you cannot actually continue to increase the limit on a particular partition. So you may have to repartition it. Either maybe you create a totally different collection or maybe totally different database just for that hot guy, and the other guys, they will not be affected. Or you can do random, and there are like problems with that too. So you can randomly now sending the request, because these guys were underutilized. Now your request will get here, 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 depending on how it was hashed. But the problem is with this approach, how would you list things for a particular customer or for a particular tenant? Because now his data could be here and here. So you may have a lot of cross partition queries, right, to aggregate somewhere, because now you are making call to each of this. So that is another idea, like another approach. So you have to think about that. You can also have a service actually which has all this mapping, because now your partitioning scheme is changing frequently. So now this service cannot rely on directly like going through a simple load balancer. So you can have a service which is called actually directory, which will know where the data lives for a particular like request, things like that.
So my question is, so can you not shard on the user ID itself? Like, because we knew that particular tenant is getting hot. And other question I have is, can we have a scenario where the read request is going to different database than the write request?
Yes. So we can suppose if you partition by any ID, right? Don't you think you can get into the similar situation? Like So just by tenant ID, like this particular example could be solved, but you may have another scenarios where that user ID, suppose that user is a famous celebrity. It depends on the use case, right?
Okay.
Yeah, right.
Okay.
So yeah, that was the idea, like, just with one example, you can get into that problem. So you have to think about how to handle that. You can have a dedicated database. Sometimes they do that. You can have cache in front of those kind of databases, like especially for that guy, handle somehow. Um, there are other approaches, but that is like, let's not get into that for now. We know this idea at least.
Okay.
So what was the next thing on this? Okay, read and write, we were just talking about. Okay, and replication. Okay, so we will talk about replication maybe a little bit. I don't know in which order I want to bring it, but another scenario I wanted to talk about, if somebody can answer that. So your scenario is, now you have a request and you want to call a third party API. Maybe you are calling like some payment provider, because we don't own that. It's a third party service. And we want to charge something, like, the charge a customer. So this was my service. This was my payment processor I have written. Payment processor. And suppose this calls a third party API. And maybe I will have a client as usual. Maybe somewhere I have a database. Doesn't matter how it is linked. But now, problem is, now I cannot call the payment processors multiple times, right? Like, I don't want to charge a customer multiple times. So how do I, so, and I also don't want this guy to be the single point of failure. Suppose this guy was the only guy. So I can make a request to the payment gateway, through payment gateway to this like third party. Now, if I add more replicas of this payment processor, I may not know, like, I am double charging the person, like, the client or not. So what should I do? Anybody still? Any idea?
Unique ID or something, give it to the as a response so that you can use it in the further requests.
So what you are doing, like payment processor will return client a response that we will do, but we are not doing. I'm not clear. Can you elaborate?
No, I'm not sure, but I was just guessing. So payment processor can give some ID, unique ID or something for this, that they can use it for the rest of the service rather than calling it again and again.
Right. So if I think about it, if payment processor can generate something, let's call it idempotent thing, like something unique for this particular request ID or order ID or something. And if I have a mapping somewhere, so even if I have multiple replicas, right, and these guys are maybe checking maybe a distributed database where we have, before charging, you need a distributed log here before actually performing this. This may work. Was that your idea on that line?
Yeah, I mean, maybe I couldn't remember, some Twitter has some unique IDs and generation kind of thing, so that you can use it to give it as the response to the client.
Right. Right. So this is one approach to solve that. And but the problem is sometimes you cannot always generate this thing. This is not, it's not very easy. Like it's like depends from use case to use case. So I like this idea. It's a very good idea, by the way. So you should think about it. But I have another thing I wanted to bring here. So can someone guess it? It's tough maybe, but okay, I will, since we are running out of time, I will just write anything gives, like, what can we do here? Suppose out of these three instances, three replicas we have, like, we are saying that, hey, like, at one point of time, let only one guy to be the leader.
Right. Yeah, that leader election protocol or something. Yeah.
Right.
Okay.
So if we can do that, like, okay, out of these three guys, I know which one is the leader, and leader is in charge of actually handling that. The followers, or let's call it like sometimes you call it master, slave, active, passive, same kind of thing. They can get promoted as a leader if things go down, like, if the main leader is not responding. And out of that, only those guys will be, like, once a new leader is elected, now that will be actually doing all this processing. That will solve it. So now, as I said, we will briefly just dust it. So we will just touch it. What are the different leader election thing you have heard about? I will just write it down. We will not go in detail. So leader election. You may have heard about Paxos, right? You might have heard about Raft. Actually, yeah, we are talking about consensus algorithm, because leader election. So all these replicas should agree who is the leader. So for that, we have these consensus algorithm, Paxos, Raft. I think Bitcoin also has one. There are more. Uh, in terms of understanding, I think Raft is relatively easier, and Paxos has been there for a longer time. So Google has, like, their chubby lock service where they actually use this Paxos thing. And what else? So they have also a spanner database. So they have used it there. And they also talked about during, like, when they built chubby lock service, that how practically tough it is to build a system based on Paxos, like, implement in real world. And then Google Spanner has it. And you will get a lot of implementation for Raft, like, on their website. So I am not sure whether, like, what is this thing? Zookeeper. So whether it is Raft based or Paxos, I don't know, but you can use Zookeeper for this kind of, if you have to implement your own, you can use Zookeeper. You can use etcd. Uh, then there is console. You can use these already implemented thing as a small like library, or as a small framework to help you achieve this kind of like, algorithm basically. So that is possible, and that is useful when you have a single writer, right? You have just one leader and other followers. But sometimes you may need to have multiple leaders. that will become even more complex. Because now if there are two leaders, there could be more conflicts. So how the conflict resolution will be. And typically you will have different data centers have different leader, because if one leader dies, you still have another leader who is actually performing that. And then you have to have a sync up, like, when they make sure that data gets replicated, like, they have a consensus. So yeah, you can look into it also, maybe later. So that's the brief overview of this thing. I think that completes the thing I wanted to talk about. And we are running out of time also, so we may not go into too much detail. So anybody has any question at this point of time?
So in this case, the leader will make sure there's only one process payment request.
Yes, so in this particular scenario, there is only one leader is the one who will actually make a call for payment processing. Others will only chime in when the leader has died because there was some error or server crashed. You can think about a load balancer also a little bit like that. If you just allow one load balancer to handle and distribute the traffic, but for redundancy, you want more load balancers because you don't want a single point of failure, you can apply the same strategy.
Okay, so what you're saying is the the client can send multiple requests to the leader, but the leader only send one request out.
Oh, so yes, so client will not tell that, okay, charge me one more time. You will have that already, right? Like, handle that thing that, like, there is not multiple requests for double charging. But in the scenario which I described, even if client was sending request one time, and if there were multiple, like, workers here, and if they all can take this request, we can be in a situation when we double charge. So one person, I think it was Uday, he mentioned adding a lock somewhere to make sure that doesn't happen. Like, before these guys going to this, generate a unique ID that, okay, this request I am handling. So, and then updates the status that this request was handled. And this was another approach, which I'm just talking about, that you can have a leader which allows something to go through. You will have same thing like when you have one write database and multiple read database. So write only goes to one, but you don't want just one write database to have in your system. You want multiple because that guy may fail. Then would you say that I can't take any write request? You can't say that, right? So you will have more replicas which will be ready to become a leader and allow the write, right? Does that make sense?
Yeah.
Okay. So with that, I think we have touched a lot of stuff. I think we have covered things, and maybe if we do ever build, talk about real interview questions, then we now have covered a lot of areas. Then we may just talk about something newer comes up. For example, we didn't talk about batch processing at all, how that will run, like streaming applications. We didn't talk about that. Security, how client and servers, they can exchange their certificates and things like that. But if that comes, we'll talk about when we will do that kind of exercise. But other than that, I think we are in a pretty good shape that you have some ideas to go and check what is important and then make sense out of the blog posts which you will see. Probably that will make more sense, I hope.
Definitely. Thanks so much.
Yeah, thank you.
Yeah, thank you, Roger. Yeah.
This is
Thank
very
you,
good.
Roger.
Yeah, thank you so much.
Yeah, so with this, let me stop the recording and then you can tell me the real thing.